tomorrow. I just want to continue really quickly from the last problem. If we had the graph that would represent this, so if this is the problem that we just came back with the beanbag, and if we were to put this into a slope-intercept form and we were to graph it, we would get this graph right here, right? And just the question is, well, which one of these choices would actually be viable? Right? So remember we said that the total amount of points was 50. That's the number of points they need to get. They get 5 points every time they go to a round target, 8 points each time they hit a square target. So these tell us the total number of points you get from the square and the total number of points you get from the round target. When you add them up, they need to be more than 50. So when you graph this, you get a dashed line. Okay, you realize that this dotted line is because this is simply a greater than sign. There's no greater than or equal to here, it's just greater than, so it's dashed. Where it's a greater than also means that we're going to be shading above the line, so that's why we shaded above here. And we have a bunch of things down here. Now notice as well that they say let x equal the round target, so that's why down here on the x-axis it's labeled round target, and then for the y was the square target, and so that's why we have the y-axis here is the square target. All right, and some of the choices that they gave us was, is it possible then, like, could she get more than 50 points if she landed on the round 7 times and land on the square 1 time? Now what you could do is that you can definitely take this, your x and your y's, right, and you can substitute it and you can do the math and you can do all that stuff, and that's great. But if you're given a graph, that's usually the best thing to do. So on a graph, whenever you shade, this is your solution right here, right? Everything that's all of this stuff right here that's graphed, that would be your solution. So I'm just going to erase that back out so that we have a nice clean thing to work with. And 7 round, so remember x is going to be our round, y is going to be our square. Okay, so 7 times on a round, 1 time on a square gives us the coordinates 7, 1. Okay, so 7, 1 is down here, and you see that this is not in the shaded area, so this is not going to be an answer. Okay, 6 times on a round, 2 times on a square, 6 and 2 is closer, but it's not really where we need it to be. 5 times on a round, 3 times on a square, so 5 and a 1, 2, 3. Now you see how this lies on the line? Okay, possibly a solution, possibly. So we're gonna put a question mark here. Put a question mark. Well, actually, I'll just put a square around it, and then land 4 times on a round, 4 times on a square, and we see that that is going to be 1, 2, 3, 4. See, look at that. It's like right above the line. See, it's right above the line right there. So let's go back. We know that this one is definitely a solution, yes, because it's inside of the shaded area, so we know for sure that's a solution. We just need to just check to make sure that this one may or may not be. So on the side here, I'm going to write down the equation that we got. We got 5x plus 8y is greater than 50. We're using the point 5, 3. Okay, 5, 3. And we're just going to substitute the 5 for the x, the 3 for the y. So when we do this, you get 5 times 5, right, just substituting, plus 8 times 3 is greater than 50. Okay, 5 times 5 is 25. This is 24. And when you add these guys together, you get 49 is greater than 50. So this is actually not going to work, meaning that this is not a viable answer. And so thus the only one that works seems to be this guy right here. Okay, just this bottom one. Okay, all right, so let's do one more here. And it says Felix bought X pounds of grapes that cost $1.25 per pound and Y boxes of cereal that cost $2.50 per box. So we're dealing with two different things here, right? Grapes, which is why we have a whole variable just for grapes. So we're going to write that out here. X is equal to, now we're not going to write grapes, we're going to write pounds of grapes. Okay, the reason why we're doing that is because it says pounds of grapes and we already know the cost. And then Y would be boxes of cereal. And it says that he spent less than $10. So again, we're talking about inequality. Okay, remember that we have these 4 inequalities here. We can automatically eliminate 2 of them, and those 2 that we can eliminate is the greater than and the greater than or equal to. And it says, it's very tricky because it's in the words. It says less than, not that he can spend, no more than, which means that he can spend his $10, but he just can't spend more than that. It says that he spent less than, so he's not trying to spend $10. He spent less than. So because it says just that less than sign, which means we can't get to 10. This is going to be our inequality symbol. Now, so I know for sure that I'm going to write that here, less than $10. Okay, and what makes up this $10? When he goes to the store, he's buying the boxes of cereal, and he's buying, well, not boxes, I'm sorry, this is grapes, the pounds of grapes and the boxes of cereal. Okay, but it's more than that. And so just for the sake of space, I'm going to just erase this right here. I'm just going to rewrite this a little bit better. So x plus y, a little more space there. And right now, at this moment, this tells you the total amount of money. Okay, this alone does not tell you the amount of money. It tells you simply just how many boxes did he buy. But you can't just walk into a store and pick up a box and that's it, right? The thing that's associated to that box is the cost. And so he's paying $2.50 for every box of cereal, and he's paying $1.25 for every pound of grapes. Okay, now that you have this whole piece here tells you the total amount of money, right? This whole piece is the total amount of money on grapes plus the total amount of money on cereal should be less than $10 altogether. And so they've already given us a graph. So how do we then graph this? Okay, the first thing is, as always, we want to make sure it's in slope-intercept form. So we're going to subtract out 1.25. Oh, my pen is acting crazy again. Hold on. Let's try that again. Okay, subtract 1.25x from both sides. 1.25x. Bam, 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 bam. Okay, down comes this 250. Down comes this inequality symbol, that less than. This cannot be combined. Okay, this has an x. This does not have an x. So this is just going to be negative 1.25x. No, we always put this first, and then the constant, or just the number with no letter or variable. All right, and then to get the y by itself, divide each term. Okay, this is a term, each one by 250. Okay, so we're always just dividing by the number, the coefficient. So y is less than, and you put this on a calculator, you're going to get negative 1/2. And we're going to keep it as a fraction because this is going to be our slope, right? Plus 10 divided by that is going to be, I believe, 4. Right? And now you're looking down here. Now, this is a lot to look at. So before we do that, how about if we not look at the graphs and instead we just do this? Let's break it down on our own, because if you look at the graphs, it'll be so much to do. So let's see. What does this tell you? Okay, this is the starting point on which axis? On the y. Okay, so we're going to start here first and make sure that everything is going. We're starting at 4. This means that we're going to go down 1 unit. Okay, each of these spaces there is 1 unit. Then we're going to check to see that we're going to the right 2 units. Okay, then after all that's done, we then have to check to see that this is a less than. And a less than means that we're going to be shading below. And it's a less than, so we're going to have a dotted or a dashed line. Okay, so there's 5 things that we're checking for. Make sure we're correctly starting in the right place. We're moving down by 1 unit. We're moving right by 2 units. We're shading below, and it's a dotted line. So when we go back here and check now, we'll start here. Are we starting at 4? So 1, 2, 3, 4. Good. So far, this works. This starts at 4. Okay, this one starts at -4, so this one's already out. And this one also starts at -4. Not even. It starts even, who knows where that starts. Okay, so now we're just looking at these two guys. All right, does it go down 1 to the right 2? Down 1, right 2. Down 1, right 2. Good. Down 1, right 2. Down 1, right 2. Okay, good. So this satisfies that one too. So now we have all three of these guys here. Is it a dotted line? Both of them are dotted lines. Perfect. Okay. Did we shade below? Well, it's going down, and this is actually above. If you're going down, then this would be below. So this is going to be the one that we're going to choose that represents this. Okay.